In this video, we're going to explore a little bit more in depth the EP800 by Bluetti, and we're going to do some load testing, explore the app, and do some fun tests that you may not be able to find anywhere else. And by the end of the video, my goal is to teach you more about the features and the capabilities of the EP800. And to be quite honest, I think you'll be surprised about what this system is capable of. Hey everyone, it's Justin from Justin's Project. If you're new here, I focus on testing all sorts of energy related products and building out a sustainable lifestyle. I openly share my successes, my failures, and everything in between. So if you're interested in those type of things, consider subscribing to the channel. And also throughout this entire video, I'm gonna be mentioning different products, and everything that I mention will be in the links in the description below. Now let's go have some fun. And for anyone that hasn't heard of Bluetti, allow me to introduce you real quick. This company was founded 12 years ago, back in 2012, and they offer a slew of products ranging from portable power stations to modular energy storage systems, accommodating the grid-connected home, the off-grid dwellings, and even commercial use. Bluetti is a trusted brand with cutting-edge technologies that continue to bring new products to the market on a regular basis. Their ESS systems and portable power stations are trusted by millions of customers around the globe, and the power core of Bluetti stands for quality, strength, and stability. They serve solar installers, distributors, commercial, residential, and individual users. Now, Bluetti's mission is to deliver clean energy solutions to empower communities and individuals. To find out more, you can check out their website at bluettipower.com or find the link in the description below. And before we get started, I think it's important to understand the differences between a portable power station and an energy storage system. On a portable power station, typically you have a plug right here that is a 30 amp plug, and you connect that to a transfer switch. On a energy storage system, this hooks in connected as a permanent solution into your transfer switch. I'll show you how this connects into a transfer switch a little later in the video, but I just want to give a basic overview of the differences between the ESS and a portable power station. This output is 2400 watts. This output is 7,600 watts. This is 240 volts. This is 120 volts. This just gives you more flexibility out in the field when you got DC outputs. You got your USB outputs here. You got different things that you can turn on. This is geared more toward portability. And although you can expand that, it does not represent what this represents. If your goal is to back up an entire house, you need to be looking at an ESS system like the EP800 paired with these B500 batteries. Each one of those are capable of 4,960 watt hours each one. So we have a lot of capacity right here, close to 15 kilowatt hours. And I've done a full review on the AC200L. If you'd like to check that out, I'll have that up here in the right-hand corner for you, linked into the cards and in the description below. This is just another Bluetti product that absolutely blew me away. I have their portable power station and their ESS systems. The B500 batteries are LiPo4 batteries, and I'm assuming that by now everyone knows that these are the most safe, durable, and long-lasting batteries that you can find on the market. Plus, Bluetti offers a 10-year warranty on this system, and the company's stable. They have a massive footprint in this category, and they're focused on serving their customers. I'm usually reluctant on warranty offers, but knowing that the company's background and the vision, I'm more comfortable knowing that they will honor the warranty if it's ever needed. And this is referred to as a modular design. This is an all-in-one system that integrates the inverter and the batteries. And you can start out with 2 batteries, which is 9,920 watt hours, or you can expand this to 4 batteries, which is 19,840 watt hours. Or what I have here is 3 batteries for a total of 14,880 watt hours. And the EP800 might be the most adaptable modular unit on the market. I have this connected to an existing solar system and a new mobile solar system. That one is AC, this one is DC direct. So my AC has 27 microinverters that is fed into my main panel. And then from the main panel, I have that connected into a breaker that comes over here through this switch. And then we feed in and we can charge these batteries with AC. That is a lot less productive because we have to convert at the roof, and then we come back down to here, and then we're kind of converting back into DC, put it into the batteries, then back into AC, and feeding the house with through the transfer switch. That's AC coupling. We could do DC coupling over here, which is basically what we're doing because we have that little solar array. We're coming into this temporary setup that we have here and feeding that DC power into this inverter. This inverter then feeds into these batteries and charges the batteries. Then the battery sends back out to our load center and feeds the circuits in the house. And I know I'm going to get a comment about the efficiency of converting DC to AC at the roof, and then AC to DC at the inverter, and then again DC to AC to power the load. That is not the priority of this system. The way that this is set up is to prioritize the DC first. On a sunny day like today, we're producing the power to charge up the batteries and to feed the circuits. On a very cloudy week, because we can get 3, 4, 5, 6 days of just solid clouds that wouldn't give us enough solar production, then we wouldn't be able to keep these batteries charged or to power the circuit load. That's where the AC coupling comes in and gives me an extra layer of protection, because for the most part, we always have a source of power, whether it's coming from the AC feeding into the inverter and doing its thing and sending it back out to the circuit load, or it's DC coming in, feeding it into the batteries and back into the circuit load. Or if this power is off and it's nighttime, we're not doing any production, then hopefully we have enough capacity in the batteries to get us through the night, maybe the next day if it's a little bit cloudy, and then the inverter sends it back to the circuit load. So no matter what scenario we're in, we are pretty much covered. And that's what I mean by the adaptability of this system. You can actually use this and not even have solar array at all hooked up to it. If you want to just use this as a battery backup to your house, you can do that. So no matter if you got an AC coupled, DC coupled, or not coupled at all, this could be a solution for you to have backup power when the power goes out. And the EP800 is equipped with an uninterrupted power supply, and that's referred to as a UPS function. And what that basically means is how fast can it switch from one source of power to another source of power and you not see any type of disruption. The faster the number, the better. This one can switch from one source to another source 5 times faster than a blink of an eye at 20 milliseconds. So you'll never experience a problem when it switches from one source of power to another source of power. And you can have control over the system directly from the Bluetti app from anywhere in the world. So let's take a closer look into the app and discover what features I love most about the system. And here we are on the home screen of the app, and we can easily identify the status, the energy flow, and the inverter status. So I'm going to talk about those 3 points real quick, because obviously we can see the energy flow right here. We've got 2.3 kilowatts of production coming in, feeding the battery, and 235 watts feeding the circuits right now. We actually have 0 watts coming from the grid, so we're running completely off grid. So our operation status is that we're functioning as we should, and our inverter status down here at the bottom is showing grid connection operation. We can have this turn to off-grid operation, and there is another point that I want to make, and we can change the working modes inside the app. So if we go up to that little gear in the right-hand corner and we scroll down to time of use, which is the working modes, we have 3 options to pick from: backup, self-consumption, and time of use. Currently, I'm set in time of use, but let's touch base on backup. In the backup mode, the system's going to prioritize keeping the batteries fully charged, then using the power from the connected solar array or the grid to power the circuits. And if we come back to the home screen, you'll see that everything is prioritizing toward the battery, whether it's the DC connected or the grid sending power to it. It's prioritizing getting that battery back to 100% and then sending whatever power is needed to power the circuits. And this is a good mode to have it set on if you know bad weather is coming in your area, because it's going to prioritize getting those batteries back to 100%. So if you have a power outage, you're going to have backup power. Now we're going to move over to the self-consumption. So we'll go back in, we'll go down to our working mode, we'll go into the backup and then self-consumption. In this mode, the system is going to prioritize direct solar energy consumption for household needs. Any surplus energy is stored in the batteries for power outages or when the solar production is not available. This mode is a great choice if you're going to be running completely off grid. So let's head back over to the home screen. The AC has been disconnected, and now we're prioritizing the solar connection to charge the batteries and feed the circuits. And let's head back over to the last working mode, which is going to be your time of use. And what this is, you can actually schedule when you're going to be using your AC power or the DC power, because you can avoid those peak hour rates by setting a schedule to do that. And you can see here, I got some examples that I have off peak, and then I have peak, and then I have off peak. So if you're going to set this, you got to start with the earliest time going into the latest time. So I had to set one period of time between midnight and 7:59 a.m. And then my peak hours would start at 8 in the morning till 6 o'clock at night. And then again, it goes off peak between 6:01 and midnight. So we head back over here. You can set your state of charge. I set mine at 90. It seems to be working well there. And if we go back, so right now we're in peak hours. So we're going to prioritize the DC connection. And we're doing the solar production to charge the batteries back up to 100% and to power the load. If we didn't have any solar production currently, then we would be pulling power from the batteries to cover this essential load. Now, after 6 o'clock, we can now start using the grid again because we're at lower peak hours and we're saving money by doing that. And this is ideal for areas with time-based electricity pricing. This would be a great option to avoid those peak rates, essentially eliminating peak pricing altogether. You can set up to 6 different times to match the times exactly for your peak hour and non-peak hour rates. And if you're interested in downloading the Bluetti app, I'll have a link in the description below. And I have this system hooked up to 6 400-watt Apto solar panels outside. Let's take a look at those. And I've showcased these panels on the channel before, but we have all 6 of these hooked up and we're producing at a maximum of around 2,400 watts when we're in perfect conditions. These are bifacial gain, but we don't have much of a gain because they're not much off the ground. This is a temporary setup and we're going to get about a maximum of 2,400 watts out of those. And why that's important is because with only 2,400 watts going into the EP800, we're able to power every light, every outlet, and a water heater in our house. And now that we understand the power that we're receiving from the solar system, we're going to do some load testing on this EP800. We got it AC grid connected. We have solar going into it at 2,400 watts and an inverter of 7,600 watts. We do have clouds going in and out today, so we may not have the perfect conditions, but I think we're going to get a really good test. And load testing is always very interesting. First, I'm going to attempt to reach 7,000 watts on this inverter because I'm powering 11 circuits up here. And if you didn't see my install video on this, I'll have a link in the cards, which then we'll put a link on this video up here in your right-hand corner. You'll be able to check that out. So you'll see exactly what circuits that I'm powering. But just off the top of my head, we're gonna be powering all the lights, all the plugs, and a hot water heater. So first we'll start with the hot water. We'll turn on the hot water to engage the hot water heater. And this is an electric hot water heater, so this is a major consumer of power. And while we're waiting on the hot water heater to fully engage, we'll go ahead and flip on all of the lights in the house. We have 4 ceiling fans that we're going to turn on. And we have this refrigerator running, those 2 freezers backed up. And we don't want to forget the TV and the home stereo system, coffee maker, and a Ninja Foodie. And you can see that we're running at 7.8 kilowatts of consumption. We're producing 2.3 kilowatts of solar production, and we're pulling 620 watts from the grid with a little bit coming from the battery as well, it looks like. I'm gonna let this go for about 10 to 15 minutes for a short-term load capacity. And while we have this under a large load, I thought it would be pretty cool to see exactly what the sound level was coming out of this. This is one of the quietest inverters that I've ever experienced. Sound reading, we're about 18 inches away right here. 39 to 40 decibels. That is extremely quiet for an inverter of this size. And while we're doing some fun tests, let's get a thermal scan of the inverter itself and see how hot it is. The hottest point that I'm seeing right now is 110 Fahrenheit on this side. And if we come around over here, we don't have anything over 85 degrees. So that is keeping the system really cool, especially since we have a large load put on this inverter at the moment. So let's look at the batteries. We don't have anything heating up there. This is understandable and very acceptable to be 108 to 115 Fahrenheit when you got that large of a load on there. We'll see that the electrical panels, everything is cool there. So this thing is is rocking, man. This thing's awesome. And after about 15 minutes, everything is still operating completely flawlessly. We're still consuming around 7.7 kilowatt hours. It's fluctuating anywhere from 6 to 7 kilowatt hours, depending on what's going on in the house with all those circuits turned on. But I'm super impressed with this, especially on the short term. Now I want to do a long-term 24-hour load test. We'll set everything back to normal. I'll get this charged up to 100%, and then I'll check back in with you once we get 24 hours from right now. And while we're waiting on that to charge back up, let's walk over to the building and take a look at that power station. Currently, this is on grid. So we're powering all those lights. We're doing all the light switches here, and then we got all the receptacles throughout the entire shop that's going to be on this. So we got lights, receptacle, right? So we got 4 circuits that are running 20 amp plugs all the way around the shop. And then we have 2 circuits that are running on lights. And if we look over here, you'll see that they match up. It's going to be these 2 lights. So we got a 15, a 15. It's going to be this, and this 20 right there. Now we are not backing up the welder and bigger things like the water heater. We could do that with an ESS, but with this, I want to keep it to these type of circuits. 120 volt circuits running from a 120 volt power supply. And this is my converter that allows me to run this 240 volt transfer switch with a 120 volt portable power station. I wanted to show you how cool this was to actually power these things. So if we go into our transfer switch, now this is a manual transfer switch on this unit, where our other one happens automatically. So there's a big difference in between the power station and the EP800. But let's say if we switch over, now all of our lights that were up here are now running from the AC200L. And then if we switch these over to generator, now all of our plugs are running from the AC200L. So it's pretty cool to have different options for different scenarios that Bluetti offers. And that's just an added bonus to this video while we're waiting on that 24-hour load test. And what a difference a day makes, because today we're absolutely no sun. We have heavy cloud cover and we're not producing much solar whatsoever. Actually, we're producing a little bit more than what I anticipated, but only 490 watts. And we're consuming that hot water heater is really just eating it up. And we've been running this test for 24 hours now, and we are at 43% on the battery life. And the reason that we're at that is because we absolutely have no sun to charge those batteries up. Like you've seen previously in the video, we were able to get up around 2,400 watts, and it would be able to keep up because actually the hot water heater just kicked off, and we're only using around 300 to 500 watts, just depending on what's going on the circuit. But because we have this time of use set, we're down to 42%. So and this will make it past the 6 o'clock hour tonight. And when it does, it'll charge back up from the AC. So the 24-hour load test handled everything flawlessly. I mean, this thing has yet to disappoint me in any way. So I'm very confident with recommending it. And if you would like to learn more about this system, I'll have a link in the description below, because I think even if you're looking at other brands, you want to make sure to go check out the Bluetti EP800 if you're looking for off-grid, and the EP900 if you're looking for something to feed back to the grid. And this is not going to be my last video that I'll be doing on the EP800. I'm going to continue to do some follow-up videos on it so you guys can see how it performs over a long period of time. I just think that's important, not to do just one video on a unit that's got this type of cost associated with it, but do multiple videos and try to explain everything in as much detail as possible. And hopefully I was able to teach you something or keep you entertained throughout the video today. And if I did, I'll ask you one big favor, and that's to smash the thumbs up button. That helps me out a ton, and I hope to catch you in my next video. Oh, and I almost forgot, I do have a big surprise coming up for you guys. For anyone that's subscribed to the channel, you'll get a notification when those videos come out. But I have a really cool system or product that I'm gonna be doing a review on. I think you're gonna wanna check out. It has something similar to this.